Hello, welcome to Climate Solutions News. And we're joined today by Kelly Wanser, who's Executive Director of SilverLining, a non-profit focused on advancing scientific research to reduce climate risk. Kelly's been a leading voice on the need for robust atmospheric monitoring and for open, transparent research into climate interventions, including solar radiation modification. And we're speaking at a pivotal moment in the US. Federal cuts are dismantling parts of the NOAA's atmospheric monitoring program, and similar programs are also being cut elsewhere. And that will leave a dangerous gap, not just in our ability to monitor potential threats or forecast extreme weather, but in the data needed to drive climate innovation. So I'm delighted to welcome Kelly to talk about what's at stake, what needs to happen next, and why controversial ideas like solar geoengineering are gaining serious attention. So to start with, Kelly, please give us a bit about your personal background and what motivated you to set up SilverLining.
Thank you, Dominic, and thank you for arranging this conversation. My background, I'm the founder and executive director of SilverLining, which was started about 6 years ago. And my background is from IT infrastructure and networking, so looking at the operations of large-scale network systems. And I began asking questions about climate change about 15 years ago, and sort of gradually wound my way in. And what drove my transition to working on these issues and starting SilverLining was really looking at the problem of risk. So uncertainty and risk, particularly around the forecasts that you'll see from all climate projections coming out of the UN, that as we work on different ways of bringing down greenhouse gases, even if we're really successful, the system continues to warm for several decades. And looking at that problem and asking the question of how well can we project what that will do? How risky is that in terms of cascading changes that might make the situation, beyond our ability to control? And what do we know about, sort of bending the curve if we need to, in terms of reducing climate risk sufficiently? And so that's really led to an exploration of what we know and don't know, what data we have and don't have. And what technologies, we might need to consider in a really careful and open and societally shared way.
Let's come on to that. That's a fascinating conversation. And I'd like to start really with the consequences of the cuts that have been announced to the NOAA's atmospheric monitoring program in the US. Can you tell us a little bit about that and also what you think the implications would be?
Yeah, so in the US, they go by NOAA. They're the National Oceanic and Atmospheric Administration, and they're sort of a US-sized, supersized version of a kind of the UK Met Office and some of those functions here. So they do climate, weather, and ocean. And their mission is to serve the public interest. So the United States is interesting in its history because, it really was the driver of establishing many of the global functions for environmental, weather and climate types of structures, and then producing kind of the data to feed that. And so there are a number of U.S. agencies that work on these kind of questions, but NOAA is the central driver and developed a lot of the measurement tools, the research platforms and networks, and the approaches and methodologies for measuring different aspects of the atmosphere. And they've really propagated that out to the world. So they're actually the primary feed for a lot of the data that the rest of the world uses. And they're a somewhat unique feed for the standards, practices, calibration, kind of like the atomic clock of atmospheric instrument measurement.
And tell me, is there full funding being cut, or is it just specific programs?
Well, I think one of the challenges of the circumstances is the sort of top adjective that you hear in the United States is, it's unprecedented and uncertain. And so some of the things that are happening now are really new and different. And even the people doing them, I think, the idea that some things need to be shaken up and restructured and done in new and modern ways coming in is something that a lot of people could buy into, including at NOAA. But I think sometimes, the calibration is wrong or, maybe not quite what was expected. And so everyone's learning about the value of these things as they pertain to, some of what was more obvious and some was less obvious about how ultimately measuring the atmosphere is about, weather, the economy, national security, these kind of issues. So what's happening right now is, there's some fast moving things that mean that, certain really key teams and people are starting to get cut from NOAA. And there's a lack of clarity whether, kind of the whole laboratories that support some of these functions will be, disbanded. And in that case, then some of these critical programs that combine this really deep technology and quite specific and all the methodologies for how it's used around the world and the reference networks around the world, then they could be cut very abruptly in ways that are really hard to, stand up again or reproduce.
And surely there must be other people doing similar things across the world, though. Can't they just take up the slack?
Well, that's the interesting part, I think, because the U.S. Is so big and traditionally has made such big, deep investments in basic science and certain kinds of science, that some of these this knowledge and these practices are currently unique in the U.S. and in NOAA. And in a couple of particular areas that we're concerned about, one that's come on the radar, off and on over the years, but more recently is the stratosphere. And I was here for the 40th anniversary of the discovery of the ozone hole, which was a British scientist using an advanced instrument down in Antarctica, discovered the whole super specific science to interpret what they were seeing. And it's a real the recovery of the ozone hole as it's been successful is a real story of observations. And the United States developed observational capabilities to go up to the stratosphere, which is halfway to space. And so you need like special balloons, special aircraft, special instruments. And those currently are unique in the world. The US has the only aircraft for research that fly in the stratosphere. And they're configured kind of like a Lego system where they put all these specialized instruments in them. And they initiated those flights because of the ozone problem. Then they commissioned those flights in the 90s. And one of the things that we did in SilverLining when we started to talk to people about the idea that people might put things in the stratosphere on purpose, was that what scientists at NOAA told us is the top priority is to reinitiate those measurements of the stratosphere so that you have a baseline, because that's the only way you'll be able to understand that. And so those kinds of capabilities, and there's an equivalent for greenhouse gas standard measurements and aerosol standard measurements. Right now, those are relatively unique, and some of the deep expertise is very small communities of people. And some of the tech is very advanced. And so figuring out ways to sustain it and maybe realizing we need to grow, in other parts of the world, these capabilities.
And you mentioned that monitoring whether people are putting things into the stratosphere or the atmosphere. What might they be putting in there? Are you talking about bad state actors, or what would be the purpose of those kind of actions?
Well, I think that, if you look at increasingly people considering, how do we counter some of these changes in the atmosphere, because we're seeing impacts, and you have it in the low atmosphere with cloud seeding and people trying to manage drought or flooding. And in the upper atmosphere is kind of the primary place where scientists have said, well, if you wanted to cool the planet quickly, you could release aerosols into the upper atmosphere. We've seen volcanoes do it. And so there are different scenarios where people might do that. And a really one that's kind of easy to contemplate is state actors looking to mitigate what are, increasingly disastrous conditions where they are, for example. And so in that circumstance, you could have people even meaning well, but whether or not the knowledge is there to know the implications of what they're doing, and whether, say, you're the US or the UK, your science bodies have the information to know how to respond. So when we talk to policymakers in the U.S., one of the motivating factors of getting these measurements back was, if someone started activity in the stratosphere, we have enough information to respond, to even know whether to respond positively or negatively. And so that's a big consideration.
Yeah. And you mentioned the UK Met Office a little while back. Does the Met Office not have this kind of capability? Could they not expand what they're doing to pick up?
Well, I'll start by saying, the Met Office, even though it's smaller in size and scale than the U.S. capability, the UK has the deepest tradition of atmospheric science. They basically invented it. And so you have, like, the UK is neck and neck with the US in some parts of these kinds of problems, but with a lot lower levels of investment. That said, what happened last year, and the UK Met Office is like a crown jewel in the world. Many people think they have the best climate model, the best weather model. But last year, they actually disbanded their climate-related programs. And in particular, their aerosol climate research program, which is how particles affect the climate system. And that's relevant for, solar radiation modification, but also for what people were talking about last year with the reduction of pollution aerosols from ships.
And why did they do that? Was there any reason given?
So the International Maritime Organization implemented regulations to reduce, soot emissions from ships, which is quite a sensible thing to do on the surface. But over the sort of course of the couple of years that was implemented, last year there was this sort of extreme heat in the atmosphere and in the North Atlantic Ocean, which scientists, including at the Met Office, are increasingly attributing to the loss of those aerosols. And what they do, those aerosols from ships, is, they pop up into clouds. And if you look at the Earth from space, you can see the shipping lanes, or you could before they did this, by streaks in the clouds. And so they're making the clouds a little bit brighter. And that brightness is just enough to create some cooling effect of energy pushed back to space. And it's one of the big uncertainties that we have in what's going on. And we don't have the measurements that we need for all of that. But in the Met Office, their aerosol climate practice was one of the best in the world. And their climate impacts practice, one of the best in the world. But I think, like in the US, they shifted resources over to AI weather. And AI weather is a really cool tool, but it's really only going to get you a few weeks into the future. And so for all the other problems farther in the future, you really need these other programs. And so part of the discussion that we're having is, in the UK, we care from a global perspective because the Met Office is so good at these things. From a UK perspective, it's your meteorological offices that synthesize information for policymakers. And so they'll actually be weaker, especially in questions of what climate will do in the future in the UK, and also questions of what solar radiation modification will do in general.
So who do you think is going to step up and or could step up to take the place of the the NOAA or Met Office or other people doing this work?
Well, it's a little challenging because the tools are so specialized, and so there are other climate model programs and observing programs, in kind of Europe collectively. Japan has a climate model. There are individual satellite programs, but some of these things are not immediately apparent to replace, and especially ironically for people who work on SRM, the sort of aerosol climate piece and the stratosphere, because those communities are really small and specialized, and the model improvements that are needed are really important. So, we're still much encouraging a dialogue in both the US and the UK. Like, this doesn't have to be, we don't have to step fully down that path. It's very recoverable in the Met Office. This only happened last summer. And, in the US, we're still making the argument because there are lots of people in the current administration, in Congress, some of it's just the pace outpacing getting the right messages through for things that this administration cares about. So we're still optimistic. Like there's some work to do to try to maintain and retain while we have these dialogues to make sure people understand that these are, oh no, these are things you actually probably like really could appreciate more.
Okay. And you mentioned SRM, so the radiation modification. I'm sure a lot of people won't have any knowledge of what this is at all. So could you give us a quick rundown and explain what it is and also what it isn't? Because I think there's a lot of misguided understanding around it as well.
Well, thank you. Thanks for the opportunity. Essentially, solar radiation modification is where scientists landed in the answer to the question of if you needed to respond to climate change quickly, if you wanted to reverse course quickly, what are your sort of best alternatives to look at? And where they landed really in assessments in the US and the UK, and then later in Europe and the UN was, one of the ways that nature regulates the planet and keeps it in this sort of cool Goldilocks zone, which is the reflection of sunlight bouncing off clouds and particles in the atmosphere. And when you look at the Earth from space and it's this, shiny dot, that's really what that is, the sunlight reflecting back. And you can see it in nature, and then you can see it in sort of isolated cases when large volcanoes go off and the particles in the atmosphere increase and they brighten clouds, or they go up in the stratosphere and they circulate for a longer period of time, that you get an increase in that brightness. And so what scientists speculate is that if you increase the reflectivity of the atmosphere by 1 or 2%, you could offset 3 degrees or more of warming. And so by dispersing particles into the atmosphere in different ways, you can increase that reflectivity.
And what kind of particles are you talking about there? You're not talking about chemicals, you're talking about as a natural seawater or things like that?
Well, most things and most chemicals are natural to you, but I will say, so it depends on your definition of natural. There are different materials proposed for this, really trying to answer the question of how can you do this most safely? So how can you get this brightening effect that you're looking for with the fewest possible side effects?
I mean, I think your example of the shipping aerosols kind of is a case in point, just how sensitive the whole ecosystem is and how careful you need to be.
Well, in that case, it's really a case of the loss of the brightening, right? And so the brightening effect is happening, and then the question, it's a lot like medicine, is a question of efficacy and a question of side effects. And I think a lot of the things that people are intuitively concerned about, and rightfully so, are what are the side effects of this? It sounds like it would have side effects, and it does, and it can. And the really critical thing about having lots of observations and much better model representations that the observations would help to deliver is so that you can go and say, like, in a projected future world where people are putting particles into the stratosphere or brightening clouds over the ocean, how does it affect me in Belize? Or how does it affect my crops if I'm a farmer, in Essex? And so, so having the shared tools to be able to look at those questions is kind of, the ideal circumstance, because they're real. And so the material, going back to your question, is in the low atmosphere in terms of brightening clouds. Right now, pollution from ships isn't ideal. And what scientists, UK scientists actually, John Latham, proposed in the early 90s was using sea salt from the ocean. So basically a salt mist from seawater, which is one of the ways clouds get made anyway. And so that idea of taking, a fine mist of tiny sea salt particles and wafting them up to the clouds is one of the approaches. And that sounds really lovely in a way. You're using natural substances and it's clouds. But it has some real considerations in terms of when you brighten large patches of clouds of changing weather patterns. And so that's what you really need to understand, for example.
And so, are you focusing at SilverLining on the research, or are you actively involved in deployment and testing as well?
Well, we've been involved from a research perspective, and again, it's a bit like, we think of it like medicine and ourselves a bit like a medical foundation, in that understanding the boundaries of like the the particles you can generate is what is your input into, from a modeling perspective, what these things will do and what the safety parameters are. So, for example, we work with researchers who are looking at generating particles to put in the stratosphere. And there's literature from scientists estimating how much material you would need based on looking at volcanoes. But volcanoes are really a dirty way of doing it. So they made some estimates based on, how they thought you could generate particles. And when we worked with researchers, they could actually generate them in a much more fine-tuned way, where they get the size and the range of size that they're looking for. So you might need about half the mass of what was in the literature. And what that means is that changes the side effect profile in lots of ways. That's safer. And so we do research like that, which is to try to, help people identify different materials and boundaries and things like that, and then improve the models and the data environment, and then put all of that together and have it, be available to society, ideally, that people can look at it together. Lots of experts can hammer on it and that type of thing.
Great. At Climate Solutions News, we're always about the technology, and coming back to the start of our conversation, the cuts to NOAA and the cuts to services, to monitoring services elsewhere. Do you think that's going to have an implication for people being able to develop new technologies and innovations to really try and tackle the issue in this perspective?
This is a great question, especially because, a lot of the forums I'm in are all about AI. And AI is driven by data, and there are parts of the climate problem, the energy problem, really lend themselves to having more data to inform AI, to improve your projections of risk, your specific local projections of flooding and things like that. So this would be a big hit to all of the sort of analytics that are like looking upstream at climate and weather types of projections and risks. I mean, just full stop. And I think we're the industries and the world is sort of learning, all that free data upstream that we're using for these products and tools. And this is going into the financial sector now too. And so that's an immediate hit. And then I think for people who are developing solutions that are based on real world, environment, and this goes from obvious things to, we're developing solutions for the ocean to take up more carbon, right? And so all of the data about the ocean and the atmosphere are relevant to that. But also, if even in traditional infrastructure intensive industries, since the system is changing and they're looking at how to forecast where to build, how to build for resilience 30 years from now, and because the system is less stable than it was, it's a real problem. So it may hit a lot more industries than people think, very obviously, squarely, and almost anything to do with climate. But because energy is an infrastructure intensive business, almost anything to do with energy, and then data centers, and then, so it really does kind of emanate out a lot of places pretty quickly.
Well, good luck in making the case to policymakers on both sides of the Atlantic, and hopefully there'll be some measures put in place to make sure that we can continue to have the data that's needed for innovation and for kind of tackling the problems that are so immediate and pertinent.
I'll just say one more thing, that in our work with NOAA before, kind of the recent few months, we were working with NOAA on how to translate some of their work into operationalized innovation and do more scaled observations of the atmosphere as a whole. And so there are, like any disruption, there are opportunities. And there are real opportunities to change some of the ways that things are done and delivered into kind of novel and more innovative ways. And we're working on that now. And also we think for policymakers too, this is in the United States, part of the drivers of what's happening now was a focus on innovation, cost effectiveness, doing things in public-private ways. And so we're actually hopeful that there are real things to do quickly, both in innovation and in policy. So, stay tuned. And for people who are interested, feel free to reach out to me at SilverLining.
Fantastic. Kelly Wanser, Executive Director at SilverLining. Thank you very much for that insightful discussion.
Thank you, Dominic.
Thank you.